Back guys, today we are back with another problem, and today's problem is deleting a duplicate subtree. So today's problem is based on trees, okay, on trees, and what we have to do is basically we have to delete duplicate subtrees. So how we are going to delete a duplicate duplicate subtree, right? Subtree. So basically what we can see is what the approach, okay? So you know pretty much that the output is 2, 4 and 4. So if you see a subtree, the tree is 2 and 4, 4 and 4. So if you see a subtree 4, 4, 4, 2, 2. So the subtree of 1 is 2, okay? Also the subtree of 3 is 2. So the count of 2 is 2. And if you see the subtree of 2 is 4 and the subtree of 3 is 4 and again the subtree of 2 is 4. So if you see the tree have two duplicate subtrees 2, 4 and 4. Therefore, you need to return the above tree in the given form. Okay. So first we are going to say class. Okay. So in class we can define to say class solution. In this class solution, we are going to make the constructor for our node class. So we can write int data. So after that, we are going to just initialize the data over here in the node class. We are going to create a node class, and once we have created a node class, what we can do is we can create a function. Say for example, find duplicate. Okay, find duplicate. So in the find duplicate, I can pass the node, and in that I can have two possibilities, right? I have to count the frequencies and I have to store. So first, I can define an array list, say of type integer, which is going to store all the equals to storing the, I can write like this, array list of type integer, which can storing the, I can write like this, that which can store the list after deleting the which can store the duplicate elements. So storing the duplicate elements, and hash map equals to count frequencies, and finally print function what can be done is to print the array or linked list or tree in level order. No, in pre-order traversal. Pre-order. So in pre-order traversal is nothing but first left dot data will be printed. So I can write print left dot data and then print right dot data. Okay. So this now looks haphazard. I'm going to explain you with the code so that you can understand. Okay. So first, what we are basically doing is we have a class solution. We have a return type list node, which is going to make this function print all duplicates, and it has node root, okay, a node root, which is taking a root given by the user as parameter. Now I'm creating a list node duplicates equals to new array list. So in this, it will only store the duplicate values, okay, and a hash map of key and value. So key and value, frequency. So hash map will store the value along with its frequency. So the value is nothing but of string type. Value is of string type, and the because if you see the nodes, if I see the nodes, it has. I'm basically converting the hash map elements to the string. Okay, so if you see the nodes, we have a string, and the frequency is like, suppose 2 is occurring 4 times, 3 is occurring 2 times. So this is the reason why we are going to do an hash map. Okay. So in find, then we are calling the find duplicate function. We are passing the root, we are passing the hash map and the duplicates. And in return, it was just going to return the new linked list. The new linked list. Okay. So the new linked list, this operation find duplicates is performed on this new linked list, and then it is going to return the duplicates. Okay. Now next, what we can do. Now next what we can do is, let me just present it again. Yeah, we are going to create the private string find duplicates function, It is again having a string return type. It is taking a node. It is taking my hash map, as I told you. Hash map is initialized like this with a key and a value, and then it's also taking the duplicates value, okay, which is passed from the linked list. Now if the node is null, then we are going to return a hashtag. Then we are making a string known as serial string. So this serial string is nothing but it is taking the node.data. So node.data is the initial element. Suppose some value 4 is present, okay. Then plus find the duplicates node.left. So in the duplicates, suppose 3, 2, and again 3, 1. So this is, and again say 2, 1. So if I see, this is the duplicate values, and I now have to, this is the left value and this is the left value. But when I'm going with this is the right value. So that's why I'm passing the left value as duplicate values. And similarly, I'm doing the same thing for right values. Okay, the same thing I have to write for left and right. Their frequency map. This is nothing but their frequency map. This is nothing but their frequency map. Okay, frequency. And we are passing the duplicates over here in the form of an array list. Now we are using map.put serial in our map, in our hash map. We are putting serial, which is having the, which is basically we are constructing the tree. So serial map get or default serial of 0 plus 1. So basically it is saying if we get the values, we are going to put serial, or else we are going to put 0 as frequencies as we get. Okay. So if the serial value is 2, which means the frequency of a particular element is repeated twice. 3 is repeated twice. That means suppose frequency of 3 is equals to 2. So this 2 is basically saying that yes, I got one duplicate value. So this is duplicate in nature. If the question comes like this, triplicate deletion, it can be a form of question, right? They have said duplicate. What if a triplicate is there? You're just going to write 3 over here, and whenever the count is 3, it is going to delete it. Okay. In that way, that's how he's going to get the duplicates. Duplicates are once repetitive in nature. Similarly, it is going to return the serial value. Similarly, it is going to return the serial value. Serial value is nothing but find duplicates. Okay. Now we have a function void print pre-order. Why we have a pre-order print? Print pre-order, if you see over here, we must be using somewhere. Print pre-order is used to print the particular duplicate function. If you see there is a node, return. If it's null, it's return. And then it is printing in this order. First node.data, then left, and then right. Okay. So this is how it is going to be printed. That's the reason we have made this function. So now if you want to see the complete code, the complete code is available over here. This is the complete code. This code passes all test cases, and it is works on optimal time. Time complexity is also satisfied. So this is the code. If you see, we are creating a find duplicate function, and we are calling the find duplicate function over here. And this print is to print the pre-order traversal tree, because we just can't find the duplicates. We have to even print the duplicates, right? That's why we are using a print pre-order tree. Okay. So this was all about today's problem statement. I hope you could understand this problem, and we are looking forward to solving more problems. Thank you.